Hello, I'm Alexis. I'm the CEO and inventor of EveryCook. Here we see our cooking device, and over here we have the cooking interface. Today we are cooking fudges. For fudges we need some sugar and some cream. We tell EveryCook that we are starting to cook. It says I have to open the lid. Okay, the lid is open. Then it tells me to add some sugar. So I add the sugar, and on this side we see the progress bar growing. So it doesn't tell me how much sugar I have to scale, because the scaling takes place directly inside the device. I have to do it slowly so I don't put too much. A little bit more. Yeah, that's enough sugar. Now the cream. Yeah, again we have the interactive scaling. So it just shows us how much we have to add. We have a speaker built in, so we will add voice output to tell the people how much they have to add. Now we heard the beep. The beep is from our induction heater board. We have taken just the normal induction heater board, and the beep tells the user that we have turned on the heat, and every time we turn it off there's another beep that makes lots of beeps. But since we are now still in a testing phase, we are very happy to have this feedback. But soon I'll rip off that beeper out of the induction heater board and make my own outputs over the speaker we have. Since we have a Raspberry Pi inside, it's very easy to make all kinds of sounds, and we will also implement voice output. Since our database has all the text blocks we need, text to speech is very easy to implement, but one step at a time, that's coming later. So as soon as EveryCook got all the ingredients it needs, it switched to the heating up step. It heats up to 140 degrees C. That's about the temperature we need for caramelization of the sugar and the cream. Currently we are already at 130, and we keep rising. Just a little bit of stirring, not to have a heap of sugar, but as soon as it's a bit distributed, the boiling will make the rest of stirring, so we don't need no stirring at the moment. So the machine gets all the data it needs for cooking directly from the database, where we have implemented a structured recipe format that is machine readable. So we have, for each step we have the degrees of temperature, we have to get how many grams of each ingredient, and for how long that we have to do that cooking step. Having this data in a structured way is very useful for all kinds of other applications, and on our database we are currently making an API, so you can get this structured data for making maybe a cooking app or your own digital cooking device or whatever. This data will always be freely available for all kind of purposes. Of course you can come and add your recipes, your data, whatever you want into the database, so we can try to cook it in EveryCook. Since we already have very structured data, the next step we want to do is to have the products and the shops and the local farmers and whoever produces food or sells food should be inside our database, so we can directly from a recipe generate a shopping list and tell the people, look, over there's a farmer that produces delicious fresh cream, for example, to make fudges. Now we see we have some nice boiling, the steam is coming up, and yeah, it's on a good way. Temperature is now a bit down because the boiling has started, so we pull out a lot of heat out of the pan. We are now at 115 and we keep heating until we reach the 140. That means that we have already a lot of water evaporated, because as long as the water evaporates, it cools down the whole mixture. But when we have reached 140, we will automatically switch to the cooking step, which means we keep 140 degrees for 7 minutes, and at the end of these 7 minutes we'll have a perfect caramel and we can make fudges out of it. The good thing is, as soon as you have everything inside, you can take your time, spend time with your guests, talk to your guests like I'm talking to you now. From time to time I just have a short eye over to my cooking interface, but the autopilot is running, it doesn't need my attention. The interface we have made it's HTML with JavaScript, so it runs on nearly every device. Currently we have it on my laptop because yeah, it's more a habit, because I started testing with a laptop. I could also take a tablet, the smartphone, maybe even a smart TV. I haven't tested yet, but whatever understands HTML can control the EveryCook. The device itself, we have down here a very minimal interface that just tells us what is going on in the pot. H stands for hot, so we know it's hot. Now it's quite obvious because the cover is open, but if we have the lid closed, it's useful to know, oh, it's hot inside. And this is something we absolutely wanted to have on the device. Oh, we heard a beep. That means we have turned off the heat. That is because we have reached 140. And now we start regulating a constant 140 degrees. So we turn the heat on and off from time to time. We turn it off when we are 5 degrees below the value we want to keep. So at 135 in this case, we turn off, and at 141, when we have slightly exceeded the target temperature, we turn it off again. And so we keep it turning on and off and have a quite constant temperature within 5 degrees C, which still can be optimized, but I think that's precise enough for cooking. Just below our minimal interface, there's the main switch. This is useful to turn off the heat and the motor in case of any emergency, you never know. This is hardwired, completely independent of the software, as a safety feature. The 3 buttons will be used for Wi-Fi configuration, so you can switch to an access point mode where you can easily find it, configure it to your Wi-Fi, and then switch it back to the Wi-Fi networked mode, where it links into your Wi-Fi network, gets the internet and can get its update and the synchronization from the recipe platform. The other buttons can be freely programmed. We are still looking what exactly we're going to do with them. Over here we have a cutting disc that's made to fit in here. It's still pretty prototype-like, but it works. If the cover is closed, it will be about here, and with this white pusher we can push in vegetables, and the rotating disc will cut them directly into the pot where the cooking occurs. We also have a stirring unit that you can put in here that will also be moved by the motor, so constant stirring is also possible. But here we have thermal stirring through the bubbles, so no need to make this dirty. Yes. Special thanks to all the people who have helped to get us here. Special thanks to my wife, who is now behind the camera. Special thanks to Samuel, our main programmer, who made this whole interface and most of the database, a lot of the daemon that's running on the Raspberry Pi. He did an awesome job, that's why it's running now. Then we have Thomas, our CFO, who helped me to improve the business plan, so we have some investors that are interested in talking to us. Then Milan and Mark, the two industry designers. This is still the prototype version. You see it has a lot of wires on top and it's not really beautiful to look at, but the next version is coming soon. On our Facebook and Google Plus pages you can see the sketches of how we will cover that lid to make it more beautiful. Yeah, actually the Google Plus and Facebook pages are where you can get some updates on what's going on with EveryCook. On everycook.org there's our website and our recipe database. You're welcome to make an account on the recipe database, add ingredients, add your local farmer and whatever he produces, so we can collect all this data. We also want to collect data about sustainability. Is this something which is from an overused source, like some kind of fish or so, or is it sustainable food? We don't exactly know yet how to classify it, but we are very open to all kinds of inputs. And yeah, special thanks also to all the people on Flickr who share their pictures in a Creative Commons license, because that's how we get the pictures to make our database. We always look for CC by SA licenses, which means we are allowed to copy it, to reshare it, to modify it, and that's awesome. Actually, all our work, or our recipe database is also CC by SA, so reuse it somewhere, do whatever you want with it. Just share it back to us and show us your work. That could be very inspiring for the next changes we are gonna implement. Same is for the software, the whole web part of it, which is the recipe database, the cooking assistant and stuff, the daemon on the device that controls all the sensors and does the regulation. Everything is on GitHub, so fork it, modify it, use it for your project. If you do something, maybe an interactive scale or any kind of cooking device, now I think the daemon is pretty mature, so you can easily adapt it to all kinds of purposes. Hey, we're nearly finished. We're coming close. The interface tells me 40 seconds to go. Oh, it looks marvelous. Come closer, have a look inside. See, that's creamy caramel we are making. Nice and golden. And very soon will be the time where we can get it out into the molds to bring it into a nice form. Actually, yeah, we are ready. I have some silicone molds. They are heat resistant and it's good because they are stretchy, so you can stretch them a little bit to get the fudges out easily. So Let's put it in. And I nearly forgot to mention also special thanks to Lady Ada and Adafruit. We have several Adafruit parts inside here. There are some chips that I have chosen after testing them on an Adafruit board, especially the PWM chip. Yeah, there are so many chips, but if you go to Adafruit, you can buy a board, test it out if it works. And if it does what you want, you can choose the chip to implement on your own boards, like we did, because we have created the special shield for the Raspberry Pi that includes all the ADCs and PWM chips, and also a high power MOSFET for the motor and the optocoupler interface for the induction heater. That's all on a shield that you can directly plug on the Raspberry Pi. Therefore also very thanks to the Raspberry Pi Foundation. Having such a small and affordable PC was very important to us. In the last prototype we had a PC that was 3 times bigger and 3 times more expensive, and it was quite difficult to get that into the case. And now it's really easy, and the well documented GPIOs and so were very helpful to get the whole thing working together. Yes, so you see we have made nice fudges. If you have any ideas, yes, if you have any ideas about how to make marketing, guerrilla marketing around EveryCook, who could be the target audience, because we are looking for funds, we are talking to investors, and the more precise we can say that's our target group, the bigger is the chance that EveryCook goes to market one day. In the meantime, to be independent of investors, we will do a crowdfunding campaign. So go to everycook.org, subscribe to our mailing list, or even better, create an account on our recipe database and play around with it. We are open to every feedback. Currently the database is running, but there's a lot of room for improvement. So if you have a suggestion, what is especially annoying, what is missing to that database, tell it to us, and we will, as soon as possible, implement it. And if you are either on the database or in our mailing list, or fan on Facebook or fan on Google+, we will contact you and tell you when the crowdfunding is running. For example, we will give away fudges for people who support us, and many other delicious things we have cooked in EveryCook. Another goodie we want to give away for that crowdfunding will be electronics. So the Raspberry Pi Shield, the induction heater board, and other stuff. If you like to make your own digital cooking device, you could build upon the experience we have gathered in these 3 prototypes. So I think that's all. Very thanks for watching. As I said, give us feedback, contact us, and follow us on the social networks. Okay? Thanks for watching, goodbye.